Hey everyone, and welcome to JavaScript, the hard parts, classes, and prototypes. This whole session is going to be literally about like demystifying JavaScript, classes, prototypes, the prototype chain, um, all under this umbrella of object-oriented programming. I've spent and others here at Codesmith, we spent years teaching this to beginner level bootcamp students to seasoned developers that are just trying to level up and understand. And so, no matter where you're coming from, um, these ideas really trip people up, and they do that because they're like abstract. JavaScript does things its own way, and once you're able to open up and look under the hood, it'll click. It becomes powerful. So today, what my hope is for us to slow it down, whiteboard our way through it, unpack the inner wiring of how JavaScript uh, models behave, and quite frankly, this is all recorded, so you can pause it and replay as much as you need, especially when we dive into like execution context and memory, etc. And so I quite frankly just want to tell you, welcome, welcome. My name is Terry Tilley, and I'm a lead instructor and program manager here at Codesmith. And I'd like to just welcome you in to our community. Just by watching this, you're a part of the community. There's no other barrier of entry. And if you enjoy this video or you enjoy the community or anything along that lines, we just ask something that doesn't cost you much, but a few moments of time, which is go on any of your social media and just tag us if you have any takeaways from this video. Any takeaways, I don't care how small it is or how large it is. Hashtag Codesmith, and we'll be able to see it. We'll get an opportunity to respond to it, and we will appreciate you 1,000-fold. Which takes me to, quite frankly, the mission of Codesmith anyway. Irreplaceable engineers and technologists. That's what I want you to take away from this entire presentation, and trying to understand who we are and what we're about. We are all about opportunities for individuals who can literally just enjoy the satisfaction of things like becoming a new or an autonomous engineer, having an autonomous life, if you will, and solving some of the, quite frankly, complex problems that society has. And who better to do this than people who mirror society as a whole, people who understand the problems being solved, impacted by the problems that are out there today, and they have the capacities to help leverage and solve them. And so I invite you to take a peek into just the outcomes of this journey that we are tasked with. That's really what drives us. You can see our outsized outcomes each year. About 400 graduates. You see 70% of them are hired within a short time frame of graduating, and you see the average median salary there. It's not about the money, so to speak, that you see there, but more about the complexity of the problems that they solve. And so if you are interested, if you're curious, we offer two programs, a full-time program and a part-time program. Full-time program, 14 weeks long, about 3 months. And our part-time program is about 9 months long, exactly 39 weeks or so. And so two completely different campuses, different times, as you can see here listed on the screen. Full-time is Monday through Friday and Saturdays. So it's really intense for those 14 weeks. And then we have for the part-time, you'll be with us in the evenings, Monday through Thursday, and then obviously also Saturday. And so if you're trying to decide, you're like, okay, I see there's a part-time program, a full-time program. Which one would be right for me? Which one would fit? It's literally up to you. We have the exact same curriculum. It's just given in different cadences and different modules. It's spliced up differently, but you get the exact same education. You get the exact same opportunities. You get the exact same experience. So it's really up to you and what works best with your lifestyle, your loved ones, and your priorities. So choose. And if you're not sure, which one works for you, feel free to connect with our team. If you're interested in who leads these different teams, Full-Time Immersive is led by Marcelina and Sam. Fantastic individuals. I meet weekly with Marcelina right now. Then we have Jaime and Samuel over on the part-time team. Again, both teams are exceptional, along with the rest of them that are here to help you on your journey. So when I say you choose the program that works best for you, it's what works with your timeline, what works with your schedule, and what works with your lifestyle. And so our admissions process is kind of a four-step part, if you will. The four steps are: there's an application stage, and then there's our non-technical interview, a technical interview, and then a decision. Okay, so our online application is a short essay about your passion, your experience, even if you don't have a lot of experience with programming as well, or you're fairly new to programming. There's a non-technical interview where you speak with one of our team members for 30 minutes. We just want to know the person behind the keyboard, quite frankly. Then there's a technical interview where you do have to work through some JavaScript challenges. One of our fellows, our engineering fellows, they'll be assessing things like your communication, your problem solving, your skills, your JavaScript knowledge as a whole. And then after your technical interview, a member of our team will call you and give you feedback and go over next steps. If you feel intimidated, or you feel like, well, what or how do I get prepared for that technical interview? We got resources for you. There's tons of different resources. No matter where you're starting in the journey, you could be at the early stages of your journey. If you are, I invite you to start here. Okay, download our syllabus, see exactly what it is we teach, sign up for our newsletter, and then jump right over to step 2. And I want you to join our CSX Slack. So we literally have a free Slack space. Thousands of people are in there now, both graduates, people that are in the program currently, and people that, quite frankly, just enjoy the community and the different resources that are there. Then we also have our CSX online platform. This is literally a self-paced platform where you can start to learn some of those JavaScript principles and JavaScript challenges and start to really prepare yourself for things like a technical interview. We also have weekly free workshops, very similar to the one here that you're watching that's being recorded. We host live ones as well, where you'll have one of our instructors will lead through, they'll whiteboard, they diagram, we talk about it, we discuss it. It's fantastic. It was literally my first introduction to not only the Codesmith, but its pedagogy and its approach. If you're curious and you just need some questions answered, that you have a custom situation, then at any step in the process, you can literally get on a call with us. You can schedule a call with us. But maybe you need a little bit more structure. Maybe that's it. And if you do need that, we also offer, think of these as optional prerequisite courses to help you get ready for a technical interview and also for the program. We have JavaScript for beginners, which is where I would start if you're brand new. Back-to-back Saturdays, any monies that you spend and that roll over and are discounted or subtracted from the CS Prep tuition as well. CS Prep, as you see, it's 3 days during the week in the evenings, and then Saturdays, and that will be for 2 weeks. Our JavaScript for beginners is just 2 consecutive Saturdays. So we offer also a lot of generous scholarship awards. So we have scholarships not only to JavaScript for beginners, CS Prep, but also the full program, both full and partial scholarships. You may even be able to get things like discounted tuitions as well. So if you are interested, if you're trying to see what resources we have available, reach out. In that CSX Slack community, you can literally tag Amanda. She is our admissions manager over admissions for the entire Codesmith programs. She'll have the answer for you, whatever your question may be, whatever your situation may be. And then also, you can connect with any of our admissions advisors directly and maybe have a one-on-one. So you can message us on there. We'll schedule it. If you just have a quick question you want to drop it in. we are here for you. Okay. Now, I did all that introduction because I wanted you to kind of understand who we are, Codesmith, that is, that's behind this workshop. But you don't have to wait long, because what you came here for is to understand and to take a peek into classes, prototypes, and object-oriented programming. What's really unique about this is object-oriented programming is really an enormously popular paradigm. When we start to think about how we are going to structure our code, especially when it's at scale or it gains in complexity, we have to think about what are the ways that we should approach or structure or organize our functionality, our code. And so our complex code should follow some sort of structure where, number one, it gives us a couple of really key things. Firstly, is it easy for us to add on additional features and functionality? A lot of times you build out what's known as an MVP, a minimum viable product. You have it, it works, and then you want to add on functionality. That structure, that style in which you set it up matters. It matters in how easy that might be in adding that functionality. And so object-oriented programming gives us that. In addition to that, it also allows our program to be more performant. Meaning, am I efficient in how I'm writing my code? Is it lines and lines and lines of endless code, a lot of repetitive pieces? Is it efficient in terms of the amount of memory space that it uses? And then thirdly, object-oriented programming makes it easy for us to reason about, not only ourselves, but if you think about when you are especially working on a team, a lot of times you may build one piece of functionality, and then that piece of functionality now needs to be iterated on, or some features added to it by another developer. And so if there's a clear set of rules that we've structured our code in, it makes that process so much easier. And so that's what I wanted to kind of paint this picture for you, where this paradigm, it literally gives us a very powerful, very organized way to build larger, more complex programs without things spiraling into chaos. So one of the ways that we'll be able to visit and understand this, I think at a deeper level, is we're going to go on an imaginary journey today. So think of this almost as a backstage pass that you're going to get to JavaScript, object-oriented programming under the hood. When you start thinking about things like the class keyword and the prototype chain, you'll gain a deeper understanding and quite frankly, appreciation of it. So if you can with me, if you can just imagine that we were doing, so I need you to put your imaginary hat on. Imagine that we are building literally a quiz game. And so if we're building a quiz game, and let's say we had this quiz game over here, and in this quiz game, we have users. Right now I have a user with the name Will, who has score 3. I have another user with the name Tim, the score 6. And so what I have is I have data here in our quiz game, and then underneath we have functionality. But our quiz game is not just going to have 2 users. I want you to imagine we have thousands of users, hundreds of users that are all playing at the exact same time. And so we want to have some functionality that we can literally apply to any of those users. And so, for instance, if we need the ability to increase their score, then this is the journey that we're going to walk through in our imagination. Now, in reality, in a real, more built out production level quiz game, it's going to have tons of functionality that's going to be built all the way through it. But for us in this imaginary journey that we're going to walk through in this workshop today, we're just going to focus on this ability to increase the score. And we're going to walk through exactly what that looks like, both in its most rudimentary approach, most straightforward approach, all the way up to our object-oriented programming paradigm. So what we're going to be doing, as I said, we're going to be whiteboarding a lot of these different pieces out. And so one of the ways that if we were going to store this data, this name, Will, score 3, it'll probably have other properties associated with Will, his login, maybe an avatar, right? There'll be a lot of different pieces of data all kind of coupled together. If we're going to couple all of that data together, and then we need the functionality to be with it, pause if you want. Take a guess. What kind of data structure would probably make the most sense? An object. Absolutely right. If you guessed it, you got it. An object. An object would be a way for us to bundle up the data and then the functionality and be able to have that together in near proximity, accessible in close relationship. And so that's what we're going to be talking about. And so I invite you with me on this journey as we whiteboard. So to orient us a little bit in our virtual whiteboard, on the right here, I have a little space that I've reserved, and I've titled it Global Memory. So this is going to be our global memory space. Over here on the right hand or the left hand side, you can almost imagine this entire area as our global execution context. Okay, this is all of the area where our code is going to be executing. So if we're writing an object or creating an object, one way we could do that is literally using an object literal. So what we have here, literally, as it says, object literal, no pun intended there. We have a user, a variable with a label of user1, and its value is going to be set to an entire object. And so if we were adding this, if we were reasoning about it using technical communication, if I were reading this out loud to someone, I could say, well, looks like on this first line here, we're declaring a variable, a constant variable with a label of user1. And since it doesn't look like it's enclosed in any other execution context, the default memory place it's going to go to is the global memory. And this label is associated with our object. And so inside of our object, we actually have it looks like 3 total properties. The very first property we have is a name property. Its value is the string will. We have a score property. Its value is the number 3. And then we have an increment method. And so one of the things I'm going to be doing throughout this virtual workshop is highlighting a few things to keep you in the same alignment as far as what I'm diagramming. So when I say an increment method, if you recall, a method is simply just a function that is saved as a property on an object. And so to represent that entire definition, I'm simply putting this symbol here. And this symbol is literally representing this entire function definition. Okay. So I'll be doing that all throughout this workshop, just so you understand what I'm doing on the right-hand side in this global memory. So, like we said, our main goal is to store any relevant functionality in close proximity or near the data. The data is right there next to it. It's easily accessible. It's not stored in some other random location. We don't have to import it, anything like that. Because once you start having to do those things, it becomes way less maintainable. So after we store this in there, this line down here is going to be fundamentally something that is going to become literally the way we test all of our solutions today. So if you are following along, I'd love for you to write this down somewhere. User1.increment. And so we ask ourselves, can we do this line of code? Absolutely we can. So the way JavaScript reads top to bottom, user1 is stored inside of the global memory. And then the next thing that happens on this line is user1 dot increment. So what we have here is we're invoking the increment method on the user1 object. And so if you know, whenever we have a function invocation, whenever we have told the interpreter's told JavaScript to actually go and execute the function, then what happens is we have an execution context that opens up. And this execution context comes complete with its own local memory. And so if for us, right, we are going to peek back down here at the actual code. In reality, JavaScript is looking into the memory space at that definition there, okay? But for us, I'm just going to simply reference the code that I have printed at the bottom, and we look, there's literally just one line of code. And that line of code simply says user1 dot score plus plus. So what that's saying is we're telling JavaScript, hey, do I have a variable user1? And first thing it does is it actually checks the local memory. Does it find it here? No. And then it goes to the next available memory space that has been open, that was open when it was created. And does it find user1 there? Yes. Okay, so now that I found user1, this dot notation, okay, this dot notation, okay, always represents for JavaScript to go inside of that object and look for properties with the label that is on the right side of that dot. So user1 dot score, it's looking for a score property. And looking down there, it does indeed find a score property. And in JavaScript, plus plus is simply shorthand for adding one. So what happens here? Score gets reassigned to a new value. It now becomes 4. There's no other code inside of our local execution call, so it gets garbage collected, marked for garbage collection, aka it's just going to get erased. So this line is going to be our test line. Every single iteration we do today is going to be whether or not we can still run our data, which in this case was score, and our functionality, you'll notice, are together. If you're watching this recording, put your hands up. Data and functionality, each fist is representing one. Left hand is data, right fist is functionality. Together is what we're trying to make sure that we have achieved throughout our entire imaginary quiz game journey today. So indeed, right here, yes, we have score and increment. Both the functionality is in close relation to one another. We still are able to run it directly from our user one object. So yeah, if we move this object anywhere else in the code base, the functionality is still attached to it. And that's going to be fundamentally the thing that we want to keep in mind. Okay. So building on that, this principle of data and functionality together is the principle of encapsulation, which is essentially keeping that data and functionality together. One of the many ways that we can write this object, as we said, was a simple object literal. Now, the rest of this workshop, what we're going to do is we're going to be striving to set up our quiz game in what we call proper OOP style. I've already said it. Our ultimate goal is going to be to set up all of our data so that any relevant functionality that ever can be called on that data is right there next to it. It's easily accessible. It's not stored in some random location where we have to import it. So those are going to be really, really our key pieces. Okay. Now, making an object literal this way, just simply creating our objects, we could do that. There's other ways in JavaScript to create users as well, or to create objects as well. So in this instance, in this diagram or this block of code, we created the object and had all of the properties in it at the exact same time. We could go another route. We could simply create an empty object and then assign the properties to that object. If we do this, it literally is going to create an additional object, just as we had earlier. We had user one. Here we're going to declare an empty object user two. And then JavaScript goes to the next line of code. And what we have here is essentially line by line assigning, adding properties to objects. If you know, in JavaScript, objects are composite data types. So that means that you can add additional, they're mutable. So you can add and remove data from inside of that complex or combined data type. So we are adding in here a name property and set its value to the string Tim. A score property, set its value to the number 6. And then we're going to add an increment method. We end up with yet another way to create a user object. And so in looking at this approach, notice we're using, again, dot notation. Okay, not bracket notation. So when I say dot notation, it's these dots that we're using that are in between the name of the object and then also our label. Okay. There is a use case when you would use bracket notation. So if you don't know your variable, the key, the property name, when you don't know it until runtime, you can use bracket notation then. There's also some other quirky instances when your properties don't start with a letter. But again, 90% of the time you should be using dot notation for your objects when you're adding it. And so when we look at this approach, it works too. It works exactly the same. Could we still do user2.increment? Absolutely. We absolutely still can. We assigned our properties after creating our object, but we ended up with the exact same object literal creation at the end. And so we still have our data and our functionality together. And so kind of building on that, this is not the only two ways to create objects. There's another way in JavaScript to create objects as well. And so join me as we create our third user object using yet a third way. Definitely getting to be a little repetitive here, if you notice. But so on this first line, we're declaring an object with a label of user3 and setting it to the evaluated result of invoking the create method on the global object, passing in null. Now, if you've never seen object.create, first, when we see this null here, it's not actually doing anything in this object.create. But what object.create is doing in global memory, it literally creates the empty object. And null is not the reason it creates an empty object. No matter what we pass inside of these parentheses for object.create, it is always going to create an empty object. Okay. However, you will see that when we do pass something other than null, we do get some special bonuses. We'll come to that in a little bit. But as we know, user3, when we invoke the create method on the global object, we pass null, it creates an empty object. And then as we saw before, we are simply adding these additional properties to our object. Name, set as value to the string of Eva. Score, set as value to the number 9. And then also add an increment method. So, I don't know about you, but we're creating a lot of objects this way. I'm curious if you know what principle we're breaking by manually creating. We said we got hundreds and thousands of users. And if we were using object literals, whether we're creating them initially or we're creating them or we create the empty object first, or we use object.create. If we're manually creating these objects for our game by hand, this is going to be a terrible way to scale this application. We're going to have millions of users. And so you have to ask yourself, how would we, you can pause and see if you can answer this. How would we wrap up the code in a way that we only have to write it one time? And then it can be used multiple times after that. I hope you guessed function, because if so, then that's right. So our goal, quite frankly, for the rest of this lecture is going to be to figure out a way to efficiently create these user objects for our quiz game. Okay, so that they're set up so we can have the relevant data and the relevant functionality right next to it. So when we created this user3 object, okay, we used object.create and we passed in null, but that syntax, while it may look very unfamiliar or a lot different than our object literals, it is literally a gateway. It is a gateway to precision control over inheritance. And object.create gives us a blank canvas where we can use it with or without a built-in prototype chain. Imagine this. What if, when we are thinking about trying to counter this principle that we're breaking, known as dry? Take a guess if you know what the dry principle is. Don't repeat yourself. And we were very repetitive in the first portions of this workshop. But our goal is the rest of the way, I want us to figure out a way. We said functions could help us out. And we want to have a lot of users, but we want to be able to automate this process of creating users. We plan on having hundreds and thousands. We plan to get into tens of thousands, hundreds of thousands, even millions of users. And so we need a way to automate this process, a way that still gives us our data and functionality in close proximity to one another. And so the first solution that I would invite us to look at is generating our objects using a function. So fundamentally, we've significantly changed our approach. What we are essentially doing here is creating a factory of sorts. If you think of a factory, it keeps recreating the same product over and over. And so here we have a function labeled user creator. It's getting two pieces of data. It's getting a name and a score. You'll see on this first line, we are creating an empty object. The next line, we're assigning a property to that object. And we do that 3 times, 2 properties, and then a method. And then we're returning this new user. And so what we're going to do, we're going to diagram out exactly how this function works. And then we're going to see if we can still run our user1.increment and see if it still works. And so let's walk through what's actually happening with this under the hood. So in our very first line of code here, we are declaring a function with the label of user creator. If you recall, I am using this symbol to represent an entire function definition. But that's what's been saved over there. We are not executing any of these lines of code yet. If you're wondering, well, are we creating a new object now? No. We have simply taken the entire function definition in this declaration and stored it in global memory. And so now we move down to this line of code. This line of code, we are declaring a function, or excuse me, declaring a variable with a label of user1. And we're setting it to the evaluated result of invoking user creator, passing in the string will and the number 3. I know that was a lot. Feel free to rewind it if you want to hear that one more time. But what we are doing, if you recall from before, we're invoking a function. And when we invoke a function, we are opening up, see if you can remember, a function level execution context, also known as a local execution context. So I'm going to draw out this context for us. In this context, we've invoked user creator. We passed in the string will and the number 3. And so fundamentally, when we give a function arguments, right? So we have parameters of name and score, but we've given it arguments. We've given it actual data to be able to run and execute and complete the code that is saved in its definition. We first have to pair those parameters with those arguments. And so our first parameter, if you remember from our definition, was name. And we're going to pair that with the argument of the string will. Then we're going to pair the parameter score with the argument of the number 3. So literally, if you think about this will up here and this 3, these are getting paired with their appropriate parameters. Now this function is ready. It's ready to actually start down the path of its code. So on our first line of code, we see that we're declaring a variable new user, and setting its value to an empty object. That empty object on our very next line of code is going to be adding a name property inside of our object. And then it's setting the value to the variable inside of local memory of name. And so when we do user1 or new user.name, that's going to add our key of name inside of our object. But when we then use name as a variable name, JavaScript is going to look into the local memory for a variable name. And what it's going to do is going to grab the value at that variable, and that will become the value of our name property inside of our object. We'll repeat that same process for score. And then we see our next line is where we're going to be adding in an increment method. And so as we go through that process, we recognize that that looks very similar to what we had been doing earlier, but now we have this other line of code that says return new user. And so what that's doing, we're returning that out, and we return it back to the original area that it was called from, this entire function, user creator. If we look and peek up here, user creator was invoked by user1. And so this object winds up being the value for user1. And where have we stored the value for user1? It's in global memory. So this object, you can almost imagine that it picks up and becomes the new value for user1. Once that happens, our local execution context gets marked for garbage collection. And then JavaScript moves on to the next line of code. So we see that our first variable, user1, was created using this user creator function that is serving as a function factory for us. It is automating the creation of our objects for us. And because it is stored in the global memory, it can be reused, it can be called, it can be invoked multiple times. There's no limit on how many times it can be used. And so we see that here on the very next line, where we now are declaring a constant variable with a label of user2. Got ahead of it there. We eventually see the object in there, but I want to walk you through the local execution and the creation one more time. So when we invoke a function, user2, and we're setting it to the evaluated result of invoking user creator, passing in the string Tim and the number 5. And so as we said before, that means we are invoking for user2. We're again using this same user creator function to create our next user2 object. And so as we remember before, this opens up a new execution context for us, local execution context. We know that the first thing we pair whenever a function has been given some data, has been given an argument, is going to be pairing it with our parameter. So we know our parameter, our first parameter in our function declaration was name. And we're going to pair that with the string Tim. Our next parameter was score. We're going to pair that with the argument, the number 5. Now we're going into the body of our function, where we now check out our first line of code, where we create a const variable with a label of new user. And its value is an empty object. And then we are again going to add a name property. And we're going to set it to the value of the name variable, which is the string Tim. Then we're going to create a score property, set its value to the value of the variable score, which is the number 5. And then we're going to add our increment method. And if we recall, again, we've walked through creating our object. We've added our name property and set its value to the value of name. Did the same thing for score. We added our increment method, and now what's left, we're returning out our new user. And so our new user goes back to where it was called. It was called or invoked to be the evaluated result for user2. So that is exactly where the value of new user is going to return. And we know user 2 is saved in the global memory. And so we know then our local execution context is going to be marked for garbage collection. And we come to our final line again. So this is our test. This is our barometer. Are we still able? Are we still able to invoke the increment method on user 1, even though we created all of these objects using our function factory user creator, our function user creator, our solution 1 that we're going to do? And we do see indeed user 1.increment. We are invoking the increment method on the user 1 object. So that means we're going to open up another local execution context. We don't have any parameters in this one. So, and it also wasn't given any arguments. So there's no pairing that needs to happen. So we go right into the body of that function. If you recall, the body of that function is only one line, which is new user dot score plus plus. And if we recall from before, that means that JavaScript is going to find the new user object. It does find it in global memory. Or excuse me, user 1. And if you're wondering where I got that from, that is exactly what transpired here, user 1.increment. And so we're invoking user 1.score plus plus, which is going to go into our user 1 object, find score, change to 3 to a 4, and then our execution context gets marked for garbage collection. Okay, so we indeed are still able to do our functionality. Our data and our functionality is still together. So we ask ourselves, with this solution, what could be the problems? What could be the problems? It worked. It's a very rudimentary way, but it does work. It does indeed automate the function, the creation of our object. So we stop being dry in that aspect where we were repeating ourselves, making a lot of object literals. But now, each time we create a new user, we are creating the exact same increment function with the exact same code inside of it each time. And so if we look at our diagram, we have one increment method here. We have another increment method here. They are identical methods. And if we were to create our hundreds and then our thousands and then our tens of thousands of users, we'll see very quickly, are we also being efficient with our memory space? Our functions are really just copies. And that's the thing to kind of think about in this instance. Is there a better way? There has to be. And there is a better way. There is a better way. What I'd like to do is, what if, since the methods, the increment method is exactly the same. It is identical. What if we could create some kind of way to share this function with the other objects, the other users, so that way we just have one copy of it? Almost think of it as we put it in a store, and everyone has access to the store. Everyone can use this functionality each and every time as needed. We'll call this a function store. And when we run our functionality, if it doesn't find it on the object, it then just looks in the store. But everyone looks in the exact same store, and there we have it. There is a way to do this. There is a way to link this. And what I'd like to do is kind of diagram and walk us through what that looks like. So to orient ourselves with this block of code, we have user creator is still here. It still takes two parameters, name and score. Fundamentally, we've changed this line a little bit. We've brought back object.create, which we know creates an empty object. But this time we're not passing in null. We're passing in user function store. And so if we look kind of further down in our code, we indeed find user function store. If you look at the data type, it is simply an object. So we're taking this object and we're passing this object into object.create. And so we talked earlier that this gives us some additional functionality, some additional special features, if you will, that we can take advantage of. And so this object, if we look inside, it has two properties. It's that store we were talking about. It has an increment. So our increment method is now stored inside of our user function store. We also have a login inside of there. All the users are going to need to log in. And then down here, we have our code that looks identical. So let's diagram this. Let's walk through this and see, okay, Terry, I see that there's a store there. I see we're passing this store into object.create. Does that somehow allow the object's access to the store? We will see. So first we declare a function user creator. And set its value to a function definition. We hop down to our next const variable where we were declaring a variable by the label of user function store. And we know its value is an object with two methods inside, increment and login. So again, we created an object literal of this store that has these two methods inside of it. So clearly there's some kind of sharing that's going to happen here. So now we go down to our user one declaration. So now down here, we're declaring a function, a variable by the label of user one. And setting it to the evaluated result of invoking user creator, passing in the string will and the number 3. And so we know that anytime we have a function invocation, we're going to open up a local execution context. And so we have our variable user1. It just invoked user creator. passing in the string will, and the number 3. Just as we've done in the past, the first thing we're going to do is pair our parameters with our arguments. So we have a parameter name. We're going to pair that with the argument, the string will. We have a parameter score. We're going to pair that with an argument of the number 3. And again, we got that straight from our function invocation. And then now we're ready to go into the body of our function. And so our first line in our function is to create this new user. And we recall from before, object.create creates an empty object. But this time we passed in user function store. But even when we passed in null, it didn't do anything. There is something that's happening here, but I'll reserve to show you what it's doing later, because it doesn't add any immediate properties in the object. The object is still an empty object. And so we move on to the next one, where we are now adding some variables inside. We have a property name, set its value to the string will. Property score, set its value to the number 3. And that's it. If you look inside of our function definition, it is our function factory, if you will. It's a lot less code. This time we just have name, we just have score. Previously, we were adding increment here. We don't add that this time. We instead simply return new user out. So if we recall, new user gets returned out to where it was originally called, which was user 1. So this object gets returned out to be our value of user 1. What we didn't see with user function store, when it was passed in, it created, and I'll do a dotted line to represent this, it created a bond. And this bond was to the user function store object. So it created this bond. And so when we look at this bond that was created, we'll see why that's important in just a few. So allow me to rewrite and I said that there's a bond that's created. To this object. And so we know when the code is done For our other local execution context, it gets marked for garbage collection. And now we move to our next object, user2. So now we're declaring another object, user2, or another variable, constant variable user2, and we're setting it to the evaluated result of invoking user creator, passing in the string Tim and the number 5. And I think we've understood this process now as we've went through it a few times. We know that user2 is invoking user creator, passing in the string Tim and the number 5. And we have our local memory. We know the first thing paired is going to be our parameters. So we have the parameter name gets paired with the string Tim. We have our parameter score, which gets paired with the number 5. And then we have our new user object variable, which is set to the evaluated result of invoking the create method on the global object, passing in user function store. And so we know that fundamentally, as we've said a few times, it does create an empty object. And we said that when we are passing in user function store, there's this bond that is created. Then we go to that next line and we have our name property getting added. And it gets set to the string Tim. We have our score property added, gets set to the number 5. And then we get to return new user, where we know that means that we're going to return this out to where it was originally called, which is user2. Where's user2? User2 is in our memory. And I'll grab it out this time. But we do know, because I've kind of revealed that there's this bond that happens. And this bond also attaches to the user function store. And so we now get to our final testing line, our user1 dot increment. But before that, let's clean up our memory space. So our local execution context was done. Processing code, it gets marked for garbage collection. And now we are invoking our user1 dot increment. So we know that when we're doing a function invocation, it's going to open up a local execution context. And we know our local memory, there's no parameters and arguments that are being paired. And so what we have is simply our increment function. And if we look at our increment function for just a moment, we may notice the code in there, the syntax looks a little different this time. Inside of our increment function, we have this dot score. What I want to do is take a moment and talk about the this keyword. So the this keyword is what's known as an implicit parameter. That means it's automatically created. So every function, there is an implicit this that is declared that points to something. We don't typically whiteboard it out because if we're not having a use case for it, I try not to muddy up the diagrams. But when a regular function is declared, is created the this keyword, it's pointed at the object on which we are calling the method. So here's what I mean. If we look back at our user1 invocation, it's user1 dot increment. And so what the this keyword does when we invoke a function, so when we invoked this increment function, okay, what happened during that declaration is that the this keyword was pointed to the object that is left of the dot. So what I mean is there's a dot here and it gets pointed to what's left of the dot. What I mean is the this keyword in this instance was pointed to user 1. Meaning anytime you see the word this, JavaScript knows, oh, this? Oh, you mean you want me to go check out user 1. So it's going to go to the memory space where user 1 is. And the reason it knows that is because it's whatever object or whatever, whatever object was left of the dot. Okay, user 1 in this instance. So understanding that we are invoking what's left of the dot, user 1. So when we see this in here, in this context, this dot score plus plus, we know that this is pointing to user 1. And so JavaScript knows when it sees this to go and find user 1. It has a dot. It's going to go and find the score property. And it's going to actually increment that score. Okay. And so there's a whole step missing in here. You may be thinking, well, Terry, hold on. When we look in user 1, there was no increment in user 1. How did it know to invoke? You said user 1, it'll invoke increment. How does it know to actually go? So I intentionally left a few steps out. If you can back up with me, when we get to the line user1 dot increment, if we just go based on what we know so far, is simply that JavaScript will look inside the user1 object for increment. It finds name, it finds score, it does not find increment. What it will do is it will then look at the bond, and that bond points to this object. Then it will start looking through the properties in this object, and it will indeed find increment. That is the importance of this bond. Now, bond is not the technical name for it. It makes a bond. It creates, essentially, think of it as a link. More specifically, it creates an internal link to this user function store. And the way it does that is via the internal property called double bracket prototype. Here's what I mean. Double bracket double bracket prototype is a internal property, meaning it's hidden. It's not part of the innumerable properties on an object. So when I say a bond was created, here's what it actually looks like. So instead of it being a bond, what we essentially have is this hidden internal property, double bracket. When you see those two brackets, that denotes it's a hidden internal property. So just like you have a name property, you have a score property, there's also a hidden property called double bracket prototype. And the value of it is going to be user function store. So it is still a bond, but it's more of a link. So it links to the user function store. And so you have the same thing in user 2. So let me recap. There's a lot that just happened. So if we think about our fundamental thing that we've been creating, which was a quiz game, we're going to have hundreds and then thousands of users. Our main goal is to be able to keep our relevant data and functionality together in close proximity. And so what we are using here is the prototype chain. And by using object.create, we are able to add an internal link using an internal property to our user function store. So just by way of us using what's already built in JavaScript, which already comes standard as an available way for us to do it, we have our object.create where we pass in user function store. This creates not the internal property. The internal property is there. But what it does is it points that internal property to the user function store. That's what we're doing. So JavaScript goes in order in this prototype chain. And it will literally go to the user function store. If you ask it to use a property, that property is not available on that object. It then looks at the internal double bracket prototype property. And that internal link that we're able to make to our user function store is the key behind this entire solution. And so you would think this is it. We've done it, Terry. Was that OOP? Object-oriented programming? The next two solutions are going to take this same stuff, but we're going to automate it. And so as we start to unpack this solution that uses the prototype chain, this is our first peek into something that is incredibly valuable in JavaScript, but it's also incredibly complex, where we're able, using the prototype chain, to store a single increment function that can literally be shared across millions and millions of users. In this one object, we can literally have the JavaScript interpreter. If it doesn't find the function on user one, it looks up to that object to check if it's there. The one that our double bracket prototype, our prototype chain, our internal property is linked to. So we link these two so where when you don't find it, it automatically traverses up the prototype chain. And so what we're doing is we're just giving it a stop to find that increment function. Okay. And so we make that link using object.create. Object.create is the magical piece. And I'll be honest with you, I'm not sure if you're aware, but for those that are doing technical interviews for jobs, this prototype chain model, this solution here is a popular whiteboarding topic for mid-level interviews. So if you need to rewind and kind of walk through this whiteboard diagram, I think that would be a fantastic decision. Now, what if I told you? What if I told you that JavaScript actually has a cheat code for everything we've done so far manually? It does. It's called the new keyword. The new keyword. But it comes with its own quirks, though. It comes with its own quirks. And so our third solution, okay, our third solution with this new keyword now allows us to use that new keyword. And that's because fundamentally, while solution 2 is really strong and it works for us, there is still a problem with this solution. There is still a problem with this prototype chain solution. The one I told you is great to whiteboard in interviews. There is still a problem with it. It is beautiful. It works. But this super sophisticated linkage that we do to this user function store using object.create, it's nice, but it's not the standard way that everyone uses it. And so that takes me to our third solution. Our third solution. This isn't the standard way, but it works beautifully. But I want to take us to our third solution where we introduce the automation. We introduce the ability to automate some of this hard work that we've done so far, and that is the new keyword. So what happens when we have our new keyword? What it automates for us, as you see here, is two big things. We can automate the creation of the new user object. Instead of us having to use object.create to create our new object and create our link, it'll automate it for us. The other thing it does for us is it will also return out that new user object. But if we're going to do that, we do need to make some adjustments. Remember, it has its own quirks. And so we do need to adjust how we actually write the body of user creator. So our function that we used before to create our beautiful solution 2, we need to make some adjustments to it. Because we have to think about this. A couple of key questions at the bottom is, how do we refer to the auto-created object? How does it know where to put our single copies of functions? And so our new keyword is going to take a lot of pieces out of our function. Let's take a look. So our user creator function is back. We still have our parameters of name and score. Gone now is our use of object.create. And if we're eliminating this new user, then we no longer need this new user or this or the return keyword for that matter. The only 2 lines of code we now need in our function in our factory function, in our function that's responsible for creating our variables. And before, it was also responsible for making the internal link, making the bond. It now only has 2 lines. It only has 2 lines. 2 lines of code. This is it. It has this line and this line. Just 2. The new keyword is doing a lot of heavy lifting. We're going to walk through this. We're going to diagram it out, because I know you have questions right now. Like, okay, Terry, you told me object.create is what creates the bond. The bond is not automatically there. And so how does it link to the double bracket prototype if we aren't explicitly telling it to in this function? JavaScript needs a standard place to store these shared functions. And so before I tell you where it decides to do that, we need to cover a really, really important topic. I need to pull back the curtain on another piece of a fundamental principle, a fundamental feature of JavaScript. It's something that maybe you were aware of before, maybe you weren't. But functions in JavaScript are really just objects. Functions in JavaScript are really just objects. And so when we look at that, functions are really just objects. Here's what I mean. So functions have additional internal properties. Again, I'm not going to go through all of the internal properties, but it has another internal property called call. So it's an object that has an internal property called call. And this double bracket call, double square bracket, just means that it's not accessible programmatically, but it allows this object to be called as a function, but we still can use it as an object. Okay. You may be wondering where I'm going with this. And don't worry, I'm going to take us there. So allow me to take us on a journey where we understand this fundamental principle. Functions are also objects. So let's dissect what this means. So here I have a sample piece of code just to illustrate this point. So here we're declaring a function declaration with a label of multiply by 2 and setting its value to good old function definition. I got it. We go to the next line, and it's interesting. We see multiply by 2, the same variable that we just saved as a function. We see multiply by 2 dot stored with the assignment operator 5. If we didn't know this was a function, if this was saved as an object, what would we do? Well, we would simply add to the multiply by 2 object a property with the name of stored and set its value to the number 5. And so fundamentally, as I've mentioned, what I don't typically diagram with them because we're not using it, but this label of multiply by 2, in addition to the function definition, it also has an object form as well. And so I'm going to simply just put a plus sign. It also behaves exactly like an object. If we use this object syntax of adding a property, it will work. It's not going to error out. It's not going to do something different than it would if it was an empty object. So it is simply going to add a stored property and set its value to the number 5. So now we have, ladies and gentlemen, we have an object and a definition, both attached, both referenced, used with this label multiply by 2. And so if we go to the next line here, so we did this line. The next line here is invoking multiply by 2, passing in the number 3. So we know with function invocations, that means that we have multiply by 2. We're passing in the number 3, and we know this opens up a local execution context. We know parameters should be matched with arguments. So our parameter, if we look back at our multiply by 2 definition, our declaration, it said that there was a parameter num. So num is going to be our parameter, and then our value, our argument that was passed into multiply by 2 was the number 3. And so now if we look inside of multiply by 2, it has one line of code, which simply says return num times 2. And we know that num is simply 3. So it is simply 3 times 2, which is going to be 6. So we just stored a new property on multiply by 2, but we also invoked multiply by 2. And so fundamentally, if we go to this next line, so now that we return, so this one gets marked for garbage collection. And we go to our next line of code, multiply by 2 dot stored. If we search inside of this function, it'll return out the value of stored, which is going to be 5. There's something else here, though. It says multiply by 2 dot prototype. Prototype. I don't think we've seen that yet. We saw earlier double bracket prototype. But that's an internal property on objects. This is dot prototype, and it's like lowercase. There's also something else that is included specifically on objects that are also functions. So let me say that one more time. If it's a function and an object, it comes standard with an additional property inside of it. Not an internal property, not a hidden property, a standard property inside of it. And that property literally is prototype. And this prototype property that we don't add in it, it comes automatically in any object form of a function. Its value is an empty object. So what we have here, to recap, multiply by 2 has a function. Multiply by 2 has an object. And because it is a function and also an object, it also has another property that points to, think of it almost as a nested object inside. This object, the object of prototype, is empty. It's an empty object, but it comes standard. It's there all the time. Anytime you have a function that also is an object. So all the functions all have an object form, and all of the object forms have a prototype, and this prototype has another empty object inside of it. So that brings us back to the question. If we're using the new keyword, remember we did this detour because there was some quirkiness with our new keyword. We're making this automatic bond that we're making to the function store before. We're going to use this prototype and the object of this prototype to create our bond. So let's look at it. Let's take a look at it. Let's see exactly how that's going to play out. Okay? Because this may be the most the most fun reveal of this entire OOP lesson is that functions are both objects and functions. And we're going to use that fact that there's a default property on the object version, literally called prototype. There's an extra object, there's an extra property that has another object attached as the value of it, another empty object within the greater object. And we're going to use that prototype to replace our function store. We're going to actually take advantage of the fact that there's an object already there. And so let's take a look at that. Let's dive into this new keyword that we're talking about. Here's the complete solution without any of those crossed out lines. So this is what it looks like. We see fundamentally right out the gate. This looks very different. Very different. We have user creator. We still have our name and score parameters. But now we just got 2 lines of code. Now we're using this keyword, which we remember before. That's our implicit parameter. That points to whatever object is left of the dot that calls it. Okay. We'll see that in action. We're just adding name, we're adding score. There's no return keyword. There's no object.create. How the heck are we doing this? And so if we look fundamentally at this line, and this line is what we're doing. So user creator, we know if we use it like an object, it will behave like an object. So user creator dot prototype, we know that there's a prototype property there because we just learned before, if we declare a function above, it has an object form. Let's use it. Prototype, and we know prototype is another object. And so if we use this syntax we've been using before to store things, we are now storing this increment method on prototype. So this entire increment method now is being stored in the prototype. And then we repeat that for login. Let's diagram it. Let's diagram it out. Let's see what this looks like in diagram form. So we have our global memory back. We're going to start off with declaring our user function, our user creator function. We know its value is going to be a function definition. We go down to this next line where we're now going to utilize the object form of it. So just so we don't get confused, I put our plus sign so we know that the label user creator is responsible for the object and the function definition. Because here we're accessing the prototype property. And again, this is just a property that comes standard default on any object form of a function. And so we have our prototype object that is also inside of this object. And on this next line, we have user creator dot prototype dot increment. And the value of increment is a function definition. So we are adding an increment method inside of the prototype. Zoom in a little bit so we can see it. Let's see if I can make that a little bigger for us. And then on our next line, we're adding our login. So instead of storing this on our internal property, double bracket prototype, we are now storing both of our methods on our prototype property within our object of our function definition. So again, we're storing the same definition, but we're storing it in a different location. But how do we get there? How do we actually get there? And so now we're on our next line where we're going to declare a const user1. And set it to the evaluated result of invoking user creator with the new keyword, passing in the string Eva and the number 9. So we know a couple fundamental things that happen when we invoke a function. So we know we have user creator, and we know user creator, user1 is invoking user creator. Passing in the string Eva and the number 9. And so when we're passing in the string Eva and the number 9, we know that we've invoked this. So we open up a new execution context. We know it has a local memory. We know we need to pair our parameters with our arguments. So we still have the same parameter, name. We pair it with the string Eva. We have the same parameter score. We pair it with the number 9. And then now we go into our function body. And again, I'm up here with user creator. And we have just those 2 lines. So we know, if we recall from before, that this when it is invoked this way, and it wasn't invoked from a left of the dot, this is our function being invoked. Our new keyword does something different with this keyword. What our new keyword does is it allows us to use this as an object inside of our local memory. The value of this points to an empty object. The value of this points to an empty object. And this allows us to then add our name property with the string Eva, our score property with the number 9. And remember, I said that it automatically creates the object for us, the new keyword. So the new keyword automatically created our empty object associated with this. And then it also automatically returns out that object. If you remember those 2 fundamental things that this new keyword is doing for us. And so the new keyword is going to automatically return out our object to, in this case, user1. And then we know that our local execution context is going to get marked for garbage collection. And so we ask ourselves, what's happening here? Are we still able to use user1.increment? So let's do it. Let's invoke user1.increment. Okay. So we have our invocation. We know that brings us a local execution context. When we look inside of our increment or our user one, fundamentally, we ask ourselves the question that we asked before. Well, how is user one finding how is it actually finding? How's it finding increment? We didn't create this bond like we did before, did we? Did we create the bond? And so fundamentally, we have our double bracket prototype link. Allow me to show you where it is and expand it a little bit further. And so what or how our user creator prototype is getting accessed still. Allow me to move this a little bit wider. I want to fully illustrate this double bracket prototype because it did, when we use that new keyword to invoke user creator earlier, we said that it automatically created our empty object and it binded it with the this keyword. It also automatically returned our object out, but it also was responsible for making our internal property link to the prototype of user creator. And so what that looks like is, and I'm going to zoom in so we can actually see this. Double the value of double bracket prototype is user creator dot prototype. That's what it is specifically. So if we were just to abstract that away or abstract it over here, it would look literally like That's what our double bracket prototype, our internal property, this internal link, the prototype chain, that's where it's getting pointed now. When we use the new keyword like this, and we set it up like this, our bond is still created. Our link is still created. Our internal link to the prototype chain becomes more specific. So if we look at this, user creator dot, again, object notation, dot notation, it's still prevalent. And so what that is doing, ladies and gentlemen, is it is still giving us the link, but this time it's pointing to this prototype property on the user creator function. So the link is still there. So fundamentally, when I was asking the question earlier, of how do we know, how are we invoking increment on user one? Here's how. First, JavaScript looks at user one, it looks inside of the primary properties. We know that those are the first ones it's going to check. So it checks name, it checks score. Neither of those are increment. It then looks at the double bracket prototype, the internal property that is responsible for the prototype chain. All objects have this internal property, this double bracket prototype, and it points to the first stop in the prototype chain. And so because we use the new keyword, the first stop in this chain is indeed user creator dot prototype, meaning it's going to go now and find user creator. Then it's going to go inside the object form. It's going to find prototype. And then it's going to start to search inside of that object. And it indeed finds increment. Again, we walk through this piece by piece, bit by bit. But in reality, these things happen very quickly. But fundamentally understanding the prototype chain and how it works in JavaScript is going to be one of the most powerful pieces of object-oriented programming, where we now are enabling any function created, any object, created using the user creator function can inherit, can get passed down, can share functionality. All of the users that we create invoking user creator with the new keyword will all have their double bracket prototype point to user creator dot prototype, to what essentially becomes our new as we used it before. It's not an actual store, but we are using an object that's already there as the store. Why create an extra object when there's an object there we can use? So in order to finish our increment function, we know now that it did indeed find increment. So we've opened up our local execution context for increment. We are now looking at the definition of increment. And what we're seeing is that this dot score plus plus. And so we know from before, we talked about anytime we're invoking a method using the this keyword, what JavaScript is going to do is going to go and look at the object that method is stored on. So in this case, user one was the object that was responsible for calling It was responsible for invoking increment. And so when it sees that, it's going to go, all right, well, which object was that was left of the dot? And it's going to assign this is going to now point to user 1. And so this dot score plus plus becomes user 1 dot score plus plus. So if we look at user 1 does have a score property. We go inside of user 1. We overwrite that 9 incremented by 1. It now becomes 10. And voila, y'all, solution number 3 is complete. Our fundamental test that we started out with our quiz game was, can we store relevant data and functionality and have it linked together? And we have achieved that. We achieved it in solution 1, where we can still invoke increment directly on the object. User 1.increment works. And fundamentally, even using this solution, even using a new keyword, it still works. Now, there is one grammatical thing that is different than what we have been using before. What you may or may not have noticed is that user creator, when we set it up with the new keyword, notice we capitalized that first letter. We capitalized that first letter. And the reason we do that is because we needed a way for other developers who may come behind you to know that if they're going to invoke this function, if they're going to reuse this function, they must make sure that when they do it, they use the new keyword. Because if you try to invoke user creator without the new keyword, it will not automate all of the things you intend for it to do. Now, we don't have to capitalize this first letter, but that is kind of, think of it as a stylistic convention. If you have a function that you've set up in a way that it's going to utilize the new keyword, because if you look, our function, it doesn't have any return keyword. Okay, it's not creating an empty object. It only does that if we use the new keyword, and so it is a must that it is done in there. Okay, so we look at our complete solution 3. Using the new keyword, we have some great benefits. Okay, number 1, it is faster to write. Way less lines of code here. It's still in practice in a lot of code, especially a lot of code bases. Definitely see a lot of questions about the new keyword and its benefits, and how is the prototype chain different using the new keyword versus our solution 2, for example. But I think this would be a great spot if you are still with me on this recording. Pause here and diagram this out for yourself before we move on. Don't watch me just build the car, pop the hood, build your own version. But what I'd like to do is I'd like to highlight one more thing. At this point, JavaScript developers or devs, they collectively said, look, we get it. We get it, but is there a way that we can clean up this syntax even more? And that's where ES6 came in back in 2015, 10 years ago now. What was introduced was not new behavior. So what we see right now, the prototype of user creator of the function is being used to actually store functionality that can then be shared. We are not changing the behavior. But what we did do is we wrapped it up in something sweet. And the sweet thing that we wrapped it up in is something known as syntactic sugar. The syntactic sugar that we wrapped it up in is our class syntax. Take a moment. Let's look at the code. and understand what we're talking about here. So if you look on the far right-hand side, we are now using a different keyword, class. We still are capitalizing user creator, but now user creator, it appears to be an object, a very, very large object now. Okay. We're not using a function keyword. I don't see function on here at all. What I do see is constructor. So what we're doing, ladies and gentlemen, this constructor is our function definition that we had before. It's the same function definition we had before, but this time, because we're using it in a class, using the syntactic sugar, this extra wrapping, what we have to do is we have to put the definition using the constructor keyword. So this is our object's constructor itself. And then underneath, but still within the same large object, we still have our increment function and our login function. But these are inside of this object. So what they are methods. This works identically like the other solution, like solution 3. Under the hood, it works exactly the same. It works exactly the same. Here's what I mean. The function that we saw before, user creator, the functionality is still stored as the constructor. Adding increment and login to the prototype, when we put it inside of a class, inside this class object-like structure, when we put it inside of here, this under the hood is adding it to the prototype. This under the hood is adding it to the prototype. It is still getting added to the prototype object on the function label of user creator. What we have here is syntactic sugar. Essentially, it's a wrapper. It's an easier way to write it. It's less lines of code. If you look, user creator dot prototype dot increment, and then we actually have to do then the function keyword or empty parenthesis, and then we do this dot score. We are able to literally eliminate all of that part and this part, all of that part and this part, and simply just put the name of the method and the definition. And it works just the same. It works just the same. You also notice that with classes, we are capitalizing that first letter as well. This, ladies and gentlemen, has become, over the last several years, the new standard. Class using object-oriented programming and classes using this class-based structure and wrapping and approach has become literally the new standard. If you come from other languages similar to Python and other object-oriented programming languages, they use classes. So this is going to feel really, really familiar for it. Okay. But I'll be honest, there's still a lot of developers that can write class or use class syntax and don't realize under the hood that it's being added to the prototype of the object form of the function. Like they don't understand that part. And so what we did today, ladies and gentlemen, is we flipped over the entire hood of JavaScript. We completely looked at everything underneath the hood. Okay. But I can promise you this, you won't be one of those developers that doesn't know about how this works under the hood. You now know. Now, take this information. Okay. You are ready for even deeper engine work. What I want you to do is I want you to try building a simple class for, it could be a simple project that you build. It could be like a to-do item list or even maybe a book. Just build a class for yourself. Actually go and try it out. Try the syntax out. It takes a minute. So you get kind of used to it. It becomes the standard, becomes very easy to reason about. That, ladies and gentlemen, is the prototype chain and the importance of inheritance, where we're able to have our functions that are created using our factory function, using our user creator function, all are inheriting the functionality using the prototype chain. The double bracket prototype points to, in this case, user creator dot prototype, which is a property. So there's two things. There's a double bracket prototype, and then there's a prototype property. Internal property, property on a functions object. You're ready to keep going deep. So I invite you, if you can find the recording or look on our website and see if there's one live, I'd love for you to take a dive into our next stop in our series of JavaScript, the hard parts, which is closures and execution context. And it'll take you one step further because it is foundational to everything that is async, to React and React hooks. So you may be asking yourself, what comes next? And so if you are a beginner and you were stretching yourself in watching this recording, I invite you to go to JavaScript for Beginners. This date may have passed, but look on our website for some of our next upcoming events. We always have our promo codes going. If you are interested in JavaScript for Beginners, please take a look at that if you are in the beginning stages of your journey. I thank you. Please continue to dive deep under the hood for JavaScript. And until next time, keep coding.